This video looks at common mistakes in decimal division. So first of all, background on division and division with decimals. So A divided by B can be written several ways. It actually can also be written as a fraction, A over B. It can also be written as B into A, which is, if we're doing a paper and pencil method, this is how we actually would do the division. So this is the denominator. Let's clean that up a little. The bottom of a fraction is the denominator. The top of the fraction is called the numerator. When I write it this way, this is the number I'm dividing into is called the divisor. And the number I'm dividing into is called the dividend. The answer is called, which would go here, is called the quotient. And since when we do decimal division, we don't write the remainder. The remainder is what's left over, but we don't write the remainder when we do decimal division. So an example, and by the way, also B, what you're dividing by cannot be 0, and I'll talk about that very soon. So I'm going to talk about this very soon. So you cannot have division by 0. So division by 0 is not allowed. So for example, 3 divided by 4 is the fraction 3 over 4, and then it is the problem 4 into 3. So what we did do is we add a decimal point, add a 0, bring the decimal point straight up, put a little caret here to show where the new decimal point goes. So 4 does not go into 3, it goes 0 times. 4 goes into 30 though, 7 times, and 7 times 4 is 28. Subtract 30 minus 28 is 2. Add a 0, bring it down. 4 goes into 20 5 times. So the result of 3 divided by 4, or 3/4 as a decimal, is 0.75, which as a fraction, this is 7/10 and 5/100 is 75 over 100. So naming parts of the division problem. I just did that. This is the numerator. We'll do it again though. This is the denominator. If I do this division problem, I can also write this as 13 divided by 40, and I can write this as 40 into 13. When I write it this way, this is the divisor. This is the dividend. So now if I'm going to do this problem, 40 into 13, I will add a decimal point after the 13, bring it up, put a caret there, the new decimal point goes there. So 40 goes into 1 0 times, 40 goes into 13 0 times, 40 goes into 130 though 3 times, and 3 times 120. 3 times 40 is 120. Subtract, that's 10. Now we add a 0, bring it down. 40 goes into 100 twice. 2 times 40 is 80. Subtract, add another 0. We just keep going here. 40 goes into 200 5 times. So 5 times 40 is 200, so we have remainder 0. So in this case, my answer is 0.325. So now, why can we not have division by 0? So I cannot, for example, do 4 divided by 0. Cannot have division by 0. This is not allowed. The reason this is not allowed is because it will create a contradiction in our mathematical system. So if I allow division by 0, since anything divided by 0 is 1, that would mean 0 divided by 0 has to be 1 also. We know anything divided by itself is 1, so we would have to allow 0 divided by 0, which is 1. Well, if we allow this, so if we allow division by 0, we could divide both sides by 0, because if I have an equation, if I do one thing to one side, I have to do it to the other side also, and 0 divided by 0 has to be 1. Well, we get this result, which is not true. 4 equals 1. This is not true. So if we allow division by 0, we get contradictions. in our system, which we can't have. So when we define our system, we cannot allow division by 0 because it creates things that are false, like 4 equals 1, which obviously is not true. So mistake number one in decimal division is performing the incorrect division problem. So 4 over 5, students often, it should be 5 into 4, it's denominator and numerator, but students often do the wrong division problem. Well, 4/5 is this. This is a fraction that is less than 1. So my result has to be less than 1 here. 4/5, if this pi was completely filled in, it would equal 1, but 4/5 is less than 1. So this is a way to check to see if you're doing it right. So if my numerator is less than my denominator, my result has to be less than 1. So what I do here is 5 into 4, add a decimal point is 0. Bring the decimal point straight up. 5 goes into 40 8 times. 8 times 5 is 40. So we get 0.8, and 0.8 is 8/10, which is less than 1. That is correct. But if I did 4 into 5, which students frequently do when they first start out, we're going to get at a decimal point of 0, we're going to get a result greater than 1, which can't be true. So 4 goes into 5 once. 1 times 4 is 4. Subtract. 4 goes into 10 twice. 2 times 4 is 8. That's 10 minus 8 is 2. Add a 0. Bring it down. 4 goes to 25 times. Well, 1.25 is greater than 1, but this 4/5 is less than 1, so this can't be. You've done it wrong. So it has to be 5 into 4. Now, 6/5, the numerator is larger than the denominator, so this should be greater than 1. And 6/5 would be, here's 5/5. And another fifth makes, so this is 1 plus 1/5. And as a fraction, 1 is 5 over 5, which is 6/5. So you can check your division. Here I should get an answer greater than 1. So if I did 6 into 5, I would be wrong, because 6 goes into 5. You start seeing immediately it's going to be 0.8, but that can't be right because 0.8 is less than 1. So it has to be 5 into 6. It is always denominator into numerator when you convert a fraction to a decimal. So 5 goes to 6 once. 1 times 5 is 5. Subtract. So 6 minus 5 is 1. Bring down to 0. 5 goes into 10 twice. So that is 1.2. That makes sense. So our second mistake is misplacing the decimal point. So it helps probably if you're having trouble to make a grid and use a grid for your long division. So that's what I'm going to do here. I'm going to use a grid to do this problem. So I'm going to put the 556.3 goes outside the division bar. That's my divisor. This is my dividend, what I'm dividing into. So this is 0.1, let's do it this way. .1126. So I have to move my decimal point one place here, because what I do when I do decimal division, I count the number of places in the divisor behind a decimal point, and I move them in my quotient by one place. Because I have one place here, I need to move one place here. So my new decimal point goes here. So this is a common mistake. You got to count. So that's one place here, one place here. Then I go 56. Now, once I move decimal point, I just treat this as 563 into 1,126. You can ignore the decimal points because it's already here. So 563 goes into 1 0 times, 563 goes into 11 0 times, 563 goes into 112 0 times, and 563 goes in 1126 only one time, because 563 times 2 is 1126. Well, actually, it goes in exactly twice. So it should be 2 here. So my final answer is 0.002. Because 2 then times 563 is 1126, so I get a remainder 0. So it goes in exactly into 1126 2 times. So number 3, misplacing digits in the quotient. So this is a very common mistake I've seen with my students. So we got 0.015 or 0.15. I don't really need that 0 there. And I have into 9.345. So I have 2 places behind decimal point, so I need to move my decimal point 2 places. So my new decimal point goes here. Put a caret, put my new decimal point here. 15 goes into 9 0 times. 15 goes into 93 now, though. 15 times 6 is 90, so it goes in 6 times. 6 times 15 is 90. Notice that these must line up here. So the 6 doesn't go into 9, but it goes to 93 6 times. That 6 must go above the number it's going into. It goes into 15. 15 goes to 93 exactly 6 times. So I go 6 times 15 is 90. I must line these up. If you don't line them up, you're going to have a problem here because your decimal point's going to be in the wrong place. So subtract that's 3, bring down the 4. So now 15 goes into 34. Notice these all line up again here. 15 goes into 34 twice. 2 times 15 is 30. Okay, so then we put a 30 here, subtract 4, bring down the 5. Okay, that's 45. So then 15 goes into 45 3 times. 3 times 15 is 45. Now, a common mistake I see, this is correct, so 62.3 is the correct answer. A common mistake I see is that students put the decimal point there and then they put the 623 behind it. That's not right. You must put the 6, 15 goes to 93 6 times. You must put the 6 over what it's going into. It's going into 93. So it should be 62.3. Finally, why do we move the decimal point? So I'm going to try to explain what's going on here. So 0.708 divided by 5.9 can be written as a fraction. That should be 5.9. So what I'm going to do is this remember can be written as 5.9 into 0.708. So what I'm doing is I'm moving the decimal point 1 place here. When I move the decimal point by 1 place, every time I move it to the right 1 place, that's like multiplying by 10. So I'm really multiplying the numerator and denominator by 10. Let's make a times sign here. And if I multiply by 10 over 10, that's like equal to 1. So it's not changing the actual value of the fraction. So I multiply by 10, I'm moving the decimal point 1 place in both numbers. So that's 7.08 divided by 59, which is effectively what I'm doing here because I'm going to move decimal point 1 place here and 1 place here. So my new division problem becomes 59 into 7.08. So this is what's really going on here. I take 5.9 into 0.708. I count the number of places behind a decimal point. There's 1 place, so I move it 1 place here. I move it 1 place here. So my new decimal point goes right here. 59 goes to 70 times. 59 goes to 70 once. 1 times 59 is 59, and then that's 11. Bring down the 8, and then 59 goes to 118 twice. So my answer is 0.12. So let's do another example. So 0.0592 divided by 0.196. Let's write this as a fraction. So this is equivalent to the problem 0.126 into 0.05292. So I'm going to move decimal point 3 places here. Every time I move it to the 1 to the right, that's like multiplying by 10. So this is 10 times 10 times 10 because I moved it 3 times. Well, 10 times 10 times 10 is the same, by the way, as 10 to the third. And that's 10 times 10 is 100 times 10 is 1,000. So I'm multiplying by 10 to the third, which is 1,000, over 10 to the third. Well, that doesn't change the value of the fraction because 1 over 1, because something divided by itself is 1. So I'm moving the decimal point 3 places in both numbers. And this is going to become then 52.92 divided by 126. This is the equivalent division problem to the original problem. Now notice that's what effectively I'm doing here, because if I take 0.126 into 0.05292, I'm moving decimal point 3 places here because there's 3 places behind decimal point. Well, if I move it here 3 places, that's 1, 2, 3, my new decimal point goes here. That has effectively changed the problem to this, 52.92 divided by 126. So doing the problem now, 126 goes to 0, 0 times, 126 goes to 5, 0 times, 126 goes to 52, 0 times, 126 goes to 529, well 126 times 4, that's 24, carry it to 2 times 4 is 8, plus 2 is 10, that's 504, so that's going to go 4 times because 5 is going to be too big. So that's 504. Again, make sure you line up your digits here. So subtract now, that's going to be 25, bring down to 2, and 126 goes to 252 twice. Then 2 times 126 is 252, and that's 0. So my final answer is 0.42. This concludes the video. Hope it helped.